Alright everybody, we're going to work on problem number 7 on the homework classwork assignment, percent yield. Okay, I'm going to try this video to see how this works. Hopefully you guys will get it from here. So the first thing you need to do when you look at that equation is balance the equation. How I set up my balance equations is I put all the units from either side of the arrow and then I begin to balance from there. So if I look at this situation here, I have a calcium right here, there's only one of them, and then I look over here and I have a calcium right here, there's 3 of them. Okay, so the first thing I want to do is set that right. So I'll put a 3 in front of this, but that starts a chain reaction when I put a 3 in front of that. So now I have 3 calciums, but I have 6 chlorines. Okay, so when I do that, it changes this number here, chlorines, to 6. Okay, so then I look on this other side over here, right there, and I only have 1 chlorine. So I'm going to go ahead and just throw that 6 in there and change that to 6 chlorines. But you notice I did something to the lithiums. Okay, so now I have 6 lithiums. Looking over here, I only have 3 lithiums. So I'm going to make that 6 lithiums. So that's 2 times 3 is 6. Okay. One thing I did in my calculations is I realized that PO4 here and PO4 here didn't change, so I made that 1 atom. So that's a polyatomic ion, so I made that one thing to make it easier on me. Instead of balancing the P's and the O's, I just made that 1. So when I look over here, that 2 goes with this whole PO4, so I have 2 PO4s. And I come over here and I do the same thing. PO4 times 2 because there's no coefficient there, okay, which equals a 1, but 1 times 2 is 2. Alright, so after I balanced that, I got it balanced, and now I'm going to find the GFM for each one of these things, okay. So there's the GFM, which is 110.98 for calcium chloride. GFM for lithium, what is that, phosphate is 115.79. Then there's lithium chloride, 41.39. Calcium phosphate is 312.34. Okay, why does that matter? It matters because that's what we need to use to get to moles, okay? Because these GFMs are what we divide by to get to moles, but we need this set of grams first, right? So they gave us 82.4 grams. So I took 82.4 grams and divided that by 110.98, which is the GFM, and that's on our conversion chart, but you should know that by now. And that gave me 0.742 moles. Okay, so now I have the moles of this substance, and I have my ratios, so I can figure out all the other moles without doing anything except my little algebra. So I take 0.742 equals 3x, so I divide that by 3, and that gives me 0.247. Okay, so I know that 0.247 equals x, so we look for 1x in here. Oh, there it is right there. So I know that this, the mole calculation for this is 0.247 moles, so it's 0.247 moles. So then I take this 6 and times that by 0.247 and I get 1.48. I take the 0.247 and multiply that by 2 and I get 0.495. So now I have all the moles and I have all the GFMs, so I can figure out anything else that I need to know. So they told us we got 84.2 of this. That's how I figured out the moles. Okay, and then because of our balanced equation, I can figure out the moles for this side over here, 0.247. So I know the GFM and I know the moles, so if I want to calculate the grams, I just multiply the 0.247 times the GFM, and that gives us the calculated grams that we should have. Okay, so I should have, if I did everything exactly perfect in a perfect world, 72.3 grams of stuff. So that if I weighed it in the lab, in the laboratory, I put that on here, it would weigh 72.3 grams. That's the ideal, perfect situation. But in a lab, we don't get that. So what they're telling us is that we got 72.4 grams. Okay, so when we did it in our experiment, we put it on here, we got 72.4 grams. Okay, so now I need to take that 72 and calculate our experimental yield. So in our experiment, we got 72.4 grams. That's what we got on the scale. But what we calculated, what we should have got, was 77.3 grams. Okay, so you take 72.4, divide that by 77.3, and that gave us something on my calculator here. Let's see. 0.9366. 0.9366. So that gave us 0.9366, and then we multiply that by 100.93. We know we're just going to move the decimal point, so it's basically 93.6% yield. And that's how we calculate the percent yield. And you do this for all the problems, but the first thing you have to do is go ahead and balance the equation. Okay, so the first thing you do is balance the equation. Then you get the GFM. Then you get the moles. And then you look at what you're given and figure out what you're supposed to have. Okay, and then once you figure out what you're supposed to have, you look at what they gave you. They said this is what we ended up with. Or in our experiments, when we do these in class, do actual experiments, when we're weighing things, we're going to come up with this. And so experimental percent yield means what we got compared to what we should have gotten with the calculations. And there's lots of reasons that you may not get that, but that's how we calculate these problems and why we do them. All right, I'm going to try another video on a different thing later, but I should be moving around the room while this is playing, so helping some people out. Have a great day.